In this video, we're going to look at factoring difference of squares. So it's important that we, as we look at factoring these differences of squares, that we understand what difference of squares actually is, and we can recognize whether we're dealing with a difference of squares. So when we look at difference, we're talking about subtracting. And when we talk about squares, we're talking about two terms to the second power. So if there isn't subtraction, then we are not dealing with difference of squares. And if we don't have two things that we can have find the square root of with whole number factors, then we are not dealing with difference of squares. So notice that if we have two terms, that makes it a binomial. So we are working with binomials. So if it's not a binomial, then you need to probably do something else like factor by grouping, or if it's a trinomial, then you're going to be factoring your trinomial. So I want to show you the process with this, and then I'll show you a shortcut to it. So let's assume first that we can make a trinomial out of this. So let's start with this 4x squared minus 25. And so we're going to put in this 0x term in the middle, just so that we can see how this works as a trinomial. So if you remember from my other videos, or if you haven't seen them, I've shown how to factor trinomials. So if you need to do that, you can go and look at some of those other ones. They're on this playlist as well. But we take the first and the third and we multiply them together, and so we get negative 100x squared. And we need this to equal 0x, which means that really what we're looking for is the same number, and it's going to be positive and negative. So if we come here and we think, okay, 100, well, 10 and 10, so if we have a negative 10x and a positive 10x, then that will give us a 0x, which is what we want. So we can come in here and say 4x squared. Now we need to plug those in for that middle term. Minus 10x plus 10x minus 25. Now we pull out the greatest common factor because we're going to group these. So we can pull out a 2x in the first one, so we're left with 2x minus 5. And then we're left with then we can pull out a 5 in the second set, and we're left with a 2x minus 5. And then we see that we have a common factor of 2x minus 5. And then we have a 2x plus 5 left over. And there's nothing more we can do because there isn't a greatest common factor of any of those. But what we notice, and this is where the shortcut is that if we have a difference of squares, all it is saying the square root of the first term minus the square root of the second times the square root of the first term plus the square root of the second. And so if we look at that, the square root of 4x squared is 2x, and the square root of 25 is 5. And the square root of 4x squared is 2x, and the square root of 25 is 5. And so we see that we actually come out with the same solution here. And we've saved ourselves a lot of time so we don't have to go through and factor these trinomials. So let's take a look at B and see if we can apply that rule into what we're doing. So we see that a squared has a square root of a, and 4b squared has a square root of 2b. And we are subtracting, so it is a difference of squares. And so we take the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. And if we wanted to check it to make sure we were doing it right, we could use the FOIL method and take this and multiply this out. And we would see that we get the middle terms, a squared minus 2ab plus 2ab minus 4b squared. These middle terms cancel, and so we're left with our original. So we know that we've done it correctly. Okay, so now let's take a look at C. We have x to the fourth minus y to the fourth. So we take the square root of x to the fourth, and we get x squared. And then y to the fourth, so the square root of that is y squared. Okay, so we have x squared minus y squared times x squared plus y squared. Now we see again that we have x squared minus y squared, which is also a difference of squares. So we're able to apply our rule again. Square root of x squared is x, square root of y squared is y. We can't do anything with this one, so we just need to drop that down and say x squared plus y squared. And in this x squared minus y squared, it's a difference of squares, so we say x minus y times x plus y. And so now we really have these three factors here of x minus y, x plus y, and x squared plus y squared. All right, this final problem, we see that we have, we don't have a square root of 3 or an x cubed, and we don't have a square root of 27x. But what we can do is we can pull out a greatest common factor. So I'm going to pull out a 3x, and I'm left with x squared minus 9. Now what we notice then inside our parentheses is that it's a difference of squares. So the square root of x squared is x, the square root of 9 is 3, and then we do the square root of x squared plus the square root of 9. And then we need to drop down this factor that we pulled out originally. And we look and we say, nope, we can't do anything more, so we are done. All right, so hopefully this helps you. If it did, go ahead and like my video and take a look at some of the other videos that I have posted, and thank you for watching.